Do you guys know what the word in English explicit means? Like if something is explicit or explained explicitly.
This is very clear.
Very clear. Like if I give you explicit directions, that means it's like, okay, you're going to drive 1/3 of a mile, and then you're going to turn right, and then you're going to drive 200 feet, and then you're going to turn left, and then like explicit step-by-step directions. Something is very clear. If we're saying implied, it's usually something is understood generally, but not stated like out loud. Okay? In math, we have several times where things are implied. Let me give you an example of something very common. That symbol that we use right there, there's a general implication of that. There's something that I assume that you understand that I don't actually write. Does anybody know what that is?
Is it two?
Yeah, that there is a 2 right here. That is implied. We just generally assume that everybody understands that. Whereas when we want to change things to the cube root, we explicitly put the 3 there. Okay, so that's the difference. So there's things that are implied, and there are things that are not implied. Okay, so we're going to talk about that and how the chain rule comes into play with that. All right, so before we can do that, I need to just clarify a couple things of notation, and then we'll be able to move on. Okay, how have we learned to write the derivative of y, specifically with respect to x? How have we learned to write that, Sean?
We don't have that slide.
All right, so just to review, this is how we've learned to write that, okay? The derivative of y with respect to x. Okay, Newton wrote y prime, but when you use y prime, it is implied that the variable is x, but Newton didn't explicitly say x. He just wrote y prime, whereas Leibniz used dy dx, so it's clear what the two variables are. If we would write dy dt, it is clear what the two variables are, right? What are they? Y and t. Okay, so we like Leibniz because he is explicit about what he's doing. The derivative of y cubed with respect to x. Okay, we have learned that the derivative of y cubed with respect to x is 3y squared. We've learned that, okay? All right, now, next slide. Okay, so any variable now, the derivative of b with respect to x, we write db dx. Okay, the derivative of b, it's not 1. What's the only variable whose derivative is 1? X. X is the only derivative whose variable is 1. Okay, why? Because the derivative of x with respect to x, doesn't that look like 1? That's the only variable whose derivative is 1. No other variable has a derivative of 1. So when we write derivative b cubed, it is implied that there are parentheses there. Okay, this is where I'm getting to the implied versus explicit. The parentheses are not explicit, they are implied. So anything that has parentheses needs what rule? Chain rule. Okay, so the derivative of any variable other than x is implied that there are parentheses there, which means you need the chain rule. So the derivative of b cubed is not just 3b squared. It is 3 parentheses b squared. And because there are parentheses, we need the chain rule, and we need to have db dx on it. This is for every other variable other than x. So the derivative of x with respect to x, that's what we just talked about. That's the only one that works out to be 1. If we use the parentheses around x cubed, we're going to get 3x squared parentheses, which means we have dx dx, which is, because that's 1, that's how we get 3x squared. This is a very common mistake that people are flying through derivatives of letters other than x, and they often forget the chain rule. Okay, so any variable other than x, the implication is that you need the chain rule. Okay, now we're ready. What's the difference between an implicit and an explicit function? So now we know the difference between an implicit and explicit variable. The difference between an explicit and implicit function. An explicit function can be conveniently solved for y. In other words, it starts with y equals blank. So your calculator is programmed for this kind of function because your calculator has a button that says y equals. And so your calculator can handle every explicit function. But what if you can't solve for y equals? What if you can't get y by itself? That's called an implicit. And it's not a function anymore necessarily. It is a curve. What's the difference between a function and a curve? Go ahead, Noah. Okay, a function passes the vertical line test and a curve may or may not. It might.
It's not guaranteed.
But it's not guaranteed, okay? And so this is where we cannot get y by itself. There's no way to get y alone. So then how are you going to make a graph for the function? You can't use your calculator because your calculator only can handle explicit functions. So if I can't use my calculators, there's still a way to find a derivative, and there is, and that's what I'm going to teach you today. Here's an example. This is an implicitly defined curve, okay? This is created by a polar coordinates. You learned a little bit about polar, okay? But it's possible to find the derivative for this. Remember, derivative means what? Slope. All right, so I can pick any point on here and find the derivative. So if I zoom in on blue point here, the slope is the tangent. What kind of slope is that? Just in like the nature of it. It's positive. What about the one right above it? Also positive. What about this point A? What kind of slope does that have? Infinite. Okay. 1 over 0. Infinite slope. How about right below it right here? Negative. Okay, so look at the three that are lined up. Clearly this fails the vertical line test. And it also has different slopes. You've got 3 different kinds of slopes. You've got 2 positive slopes. They're not the same. And then you have a negative slope all in line with each other. That's why this fails the vertical line test. All right. So on the left, this is what we've done so far. Okay, up until today, we have solved for y, and we have y equals blank. And then we do our derivative rule. We decide what rule we're going to use. Okay, product rule, quotient rule, power rule, what are we going to use? And then we get dy dx equals blank. That's what we've done until today. Now from this point forward, you're going to also learn how to do an implicit curve. And you do the order opposite. You do the derivative rule first. So you're going to apply all the rules first. So you'll look at it and you'll say, okay, do I need chain rule? Do I need quotient rule? Do I need product rule? What rules do I need? And once you've done all the rules, then you're going to solve for dy dx. Good morning. You're going to get dy dx alone. Okay, so do you understand the difference? In an explicit, you start with y alone. In implicit, you don't need y alone. You do the derivatives first, but you finish with dy dx alone. You can finish with the derivative. So let me show you how this works. How do you get dy dx alone? You're going to use factoring. You're going to use solving. These are all the steps. Okay? So first is the rules. That's first. Differentiate first. And then the process of getting dy dx alone is getting everything on the same side, factoring and solving the same as you would solve for any variable. So I think you'll get it once you see it. Okay, we're finally ready. All right, this curve fails the VLT. I'm not going to show you the graph. You just have to trust me. It fails the VLT. I also know that because I can't get y alone very easily. There's really no way to get y alone when you have a y squared and a y. Okay, so we're going to apply our rules first. However, before I do that, it is going to be to your best advantage to add in all the implied parentheses. Trust me, you'll make fewer mistakes if you add parentheses where they are implied to be. Okay? So there are implied parentheses around anything that's not an x. So around that y, there's applied parentheses, and around this one, there's implied parentheses. It will also be to your advantage if you put in implied powers. And so I'm going to add the power 1 right here, an implied power. Trust me, you'll make fewer mistakes if you take the time to do that. Okay, so let's take our derivatives of 3 parentheses y squared. We just saw that in a previous problem. So the derivative, what rule will I be applying there? Power rule. So the power rule says, take this, pull it down to the front. That is going to give me 6 parentheses y. The new power is to the first, but because I have parentheses, I still need the chain rule. And so I take the chain rule based on the parentheses. The derivative of that is dy dx. Okay, does anybody still have questions on the implied parentheses? Okay, let's try the 2y plus. I'm going to do the power rule here. I am going to pull the power down to the front. That stays 2. The parentheses have what new power on it? 0. And I also need the chain rule, which will be dy dx. Don't just assume because you got to a 0 power that you're done. You're not done. There is still something on the inside. On the other side, we just have 5x. So we can just take the derivative of 5x, which we all know is 5. All right, now I want to simplify this so it looks a little cleaner. So this will be 6y dy dx plus, and then in the 2y to the 0, y to the 0, of course, is 1. So this becomes 2 dy dx, and then that's equal to 5. Now my job is to solve for dy dx. So you first ask yourself, how many dy dx's are there? 2. Are they both on the same side of the equal sign? Great. So as long as everything is on the same side of the equal sign, you can factor that out. The GCF is dy dx. So I'm going to factor out dy dx. And what will that leave me with? All right, Sam, you want to take it from there? What will that, once I factor out the dy dx? 6y plus 2. Still equal to 5. And then I just need to get dy dx by itself by doing a quick division. So dy dx, which is the slope of this curve that fails the vertical line test, is 5 over 6y plus 2. That means that this curve, even though it failed the VLT and does some swirly kind of things, I can still find the slope anywhere I want by following 5 over 6y plus 2. So I can go to any position on the curve and I can figure out what its slope is going to be. Okay, let's try any questions? Pause. Okay, let's try another one. All right, what is the slope of the tangent line to the curve at the point 3, 2? So we have the point, we need the slope. In order to find the slope, we need to find the derivative. In order to find the derivative, we need to put implicit parentheses around anything that is implied. So let's look at what's implied here. The 2x squared is fine. The 3y squared, I would suggest putting implied parentheses. In the 2xy, I would also suggest putting implied parentheses. This is 2x times y. 2x times y. Because this is a multiplication problem, what rule will I need when I get to that part? I'm going to need product rule here. All right, that I think is going to be a really beneficial step. All right, then we're ready to take our derivative. So the derivative of 2x squared is 4x minus, And now I need the derivative of 3 parentheses y squared. So that would be 6 parentheses y to the first. And those parentheses remind me that I need the chain rule on what is still in the derivative, in the parentheses. On the other side of the equal sign, I'll move on to the product rule. And so I would just recommend putting all the parts of the product rule and then just be ready to drop all the pieces in there. So we start with y. And then we take the derivative of 2x, which is just 2. And then we take 2x. And then we do the derivative of what's in the final set of parentheses. And the derivative of y is not 1, but is dy dx. And then we need minus 0 for our derivative of 6. Okay, anybody need me to walk through any part of that again? Okay, how many dy dx's do we have now? 2. Are they on the same side of the equal sign? No. So we're going to have to move things around to get everything that has a dy dx on the same side. I'm going to clean this up just a little bit before I do that. So I'll have 4x minus 6y dy dx equals 2y plus 2x dy dx. All right, I just like it to look a little bit cleaner. And then I'm going to take everything that has a dy dx and get it on the same side, and everything that doesn't have a dy dx, get it on the other side. And so that for me is going to look like negative 2x dy dx. So I just subtracted and moved this trail term here, moved it to the other side. Minus 6y dy dx equals, and then on the other side, I'm going to kick this 4x, which doesn't have a dy dx, and kick that over to the far side. So we're basically just trading sides here. So it'll be 2y minus 4x. And now we're to the point where we want to factor. So we'll take out everything we have in common on both sides. Okay, so on the left side, as you're looking at that, Nathan S., on the left side, what do you see that it has in common?
dy dx.
Anything else?
Into.
Anything else?
Negative.
And a negative. Okay, so let's take out the negative, the 2, and the dy dx. So negative 2 dy dx. Okay, and then go ahead. What does that leave me with?
X minus.
You took out the negative.
Plus 3y.
Okay. Okay. On the other side, Brandon, on the right side, what do we have in common?
2.
Okay. Leaving me with?
2 parentheses y minus 2x.
Great. Okay. And then we just want to get dy dx by itself, doing a quick division. So the numerator will be 2y minus 2x, and the denominator will be negative 2x plus 3y, which allows me then to reduce my 2's. And so the answer will have a negative in it, and we'll have y minus 2x and x plus 3y as are my denominator. So now what that tells me is I can take this loop-de-loop function that does not pass the vertical line test, and I can still find its slope at any particular single point. And so the slope is going to use that derivative, and I'm going to plug in the point 32 in for x and y into that slope. So I'll have negative fraction 2 minus 2 times 3 over 3 plus 3 times 2. So that would be negative 2 minus 6 and 3 plus 6. So negative quantity, negative 4 over 9. Or positive 4/9. Okay, any questions on that?
So for the problem above, how come you didn't factor 2 out of the 6y?
Oh, I could, for sure. I could say 5 over 2 times 3y plus 1. But there was no advantage to factoring because it wasn't going to reduce, so I didn't. But that would be fine.
No way.
Okay, great question. All right, this is our last example. Find the equation of the normal line to that problem, to that equation, at -1, 2. So I'm going to suggest, again, that we go back and we treat this with the implicit, with the respect we need, okay? I would say let's put parentheses where we think they should go. All right, so Tyler, can you try? Where would you put parentheses, at least in one place? And if you want to get them all, that's great.
One's the minus x, parentheses around the x and parentheses on the
Perfect, okay, because what will that remind you to do, hopefully?
product rule.
All right, hopefully that will trigger for you that this is going to be a product rule, okay?
And then parentheses around the y.
Yep. Okay, so it's protecting yourself from making an error down the road. Okay. Does anybody want to tackle this? How are you feeling? Leela, feeling confident? Fresh off a win yesterday? Okay, all right. What's the first derivative, or first part of it? 2x, okay.
And then you do the product rule.
Uh-huh.
4x.
Okay, so now here's another place I need you to like make an algebra thing. You are subtracting the product rule. So you need to have your subtraction. And when you set up your product rule, because you are subtracting the product rule, there should be an extra big parentheses around that because you are subtracting the whole product rule. That's a place where people will get a little careless and they will forget that the subtraction applies to the whole product rule. All right, now you want to do the product rule?
Y,
Uh-huh.
and then 1,
Yep.
and then x, and then dy.
Good job. Okay, and then plus. Okay, you want to finish it up? You're doing such a good job.
And then it's plus, we don't take the derivative
Mm-hmm.
of the chain rule.
Good. Derivative and the chain rule.
So remember 2, and then parentheses 1.
Okay.
And then you put minus dy dx.
Okay. Awesome. All right, and then finally we'll do the derivative of 7, which is 0. Sometimes I'll see students do a problem like this and they've done everything right and then they get to the derivative of 7 and they leave it as a 7 and they forget that the derivative is 0. Somebody would be like, that would be me. I would do that. Okay. All right. So now let's clean this up. Let's distribute that subtraction and then we'll look at what we've got. So we'll have 2x and then the subtraction is going to apply to the y and the subtraction will also apply to the x dy dx. And then we'll have a 2y dy dx followed by being equal to 0. So again, we have 2 dy dx's. They happen to both be on the same side already, but I have a 2x and a y that I want to move over to the other side. So that's going to leave me with negative x dy dx plus 2y dy dx, and then kicking over to the other side, we'll have negative 2x plus a positive y. So I'm just clearing space to make room for my factoring and division. So dy dx can factor out from negative x plus 2y and have me be equal to negative 2x plus 1y. So the only final thing I have to do is divide. So the division will turn into negative 2x plus y in the numerator, negative 1x plus 2y in the denominator. Those negatives don't reduce because they don't factor. They can't reduce if they didn't factor out. The 2's don't reduce because they don't factor. The y's don't reduce because they don't factor. You can't reduce without factoring. But we can plug in the point that we were given. So we are given the point negative 1, 2. And so then I'll be able to figure out the slope. So I'll take this down here and figure out the slope by plugging in those numbers. So my slope will be negative 2 times negative 1 plus 2 over negative negative 1 plus 2 times 2. So if I'm doing my math right, I'm coming up with positive 4 and positive 5. Is that the slope we need?
No.
What do we need? We need normal. So my last step would be to write a normal line. The normal line will be y minus 2 equals the normal slope, negative 5/4, over multiplied by x plus 1. You don't have to distribute that. You may leave that in point slope form, and that is our normal line. All right, any questions about implicit derivatives? Once you get the hang of it, there's really nothing to stop you other than losing a parentheses or not getting a 0 or losing a subtraction sign or something. Carla?
Use the restroom.
You know the drill, right?
Yes. Are you gonna take your time? No.